So in this video, we'll talk about meshing. Meshing is a kind of critical thing for the model because it kind of assigns how big your cell sizes are. And as you probably read through the FDS manual, everything in FDS is dependent on the mesh and the mesh size. And everything in the model will snap to a grid cell size. So our common cell size is 0.25 meters. That's what will happen when you do this and you get a new mesh like this. What PyroSim does is it's going to assign a mesh around the whole geometry. However, this is extremely inefficient, so we'll talk about how to make that more efficient. But a couple things to note as you're putting your model together. These things would be whatever your mesh is. It's just the maximum minimum constraints of your model. The number of cell size is going to be the max x minus the min x divided by the number of cells is your cell size. PyroSim lets you kind of do it on the fly, so you can make it 0.2 meters and it'll update things accordingly. You can make it 0.1 meters and it'll update things accordingly. The thing to remember when selecting your cell size is you want to make things as small and as precise as possible, but still be able to run your models within a reasonable amount of time. This is a fairly big building, so depending on what the space is, the atrium is fairly tall and fairly large, so using a mesh, hopefully the models will take less than a week or so, but you'll have to do some mesh studies to really figure out what you think the best mesh cell size is. The other thing to remember is you can change your mesh cell size depending on where you are in the building. What you want to do is you want to make the mesh precise near areas of interest and areas of activity, which for ARC purposes is usually near where the fire is. You want that to be extremely well defined. Places and locations far afield from the fire, you can probably get away with having a larger mesh because there's not as much going on. So keeping that in mind, this building is too big for one single mesh. You can see that the number of cells is 28 million, and that will never work on any computer that you try it on. So what we need to do is we need to divide up the mesh into a couple different meshes. The other thing we can notice is that this is all empty space. It's outside the building, so there's really no reason to model it. So we're going to try our best to take that out of our mesh. So the thing I like to do is use these side views like this, not like that. Like this, and then the easiest way to do it is to use these split tools to find a place where you want to split it. And so you can see that this is going to make a line at the x equals 34 line, and then you can just click it. And you can see that now it's going to divide this mesh right here. And then the other one we want to do is probably a Z1 right here. You can do that like that. And so the thing to remember when you're doing this is that when you're done, you have to right click and hit finish, otherwise it won't save. And so now we have four meshes. This one kind of nominally surrounds the bottom of the atrium. This one is kind of the hotel tower. This one is the movie and ballroom area, and this is the empty space. And so what we can do with this is we can just delete it. So I already, one of the things that I like to do when doing this is try to do it in Excel, because one of the things we want to do when we're optimizing the mesh is to try to make the number of mesh or cells in each mesh below 500,000 or around 500,000, but never make it more than 1 million. So right now it looks like all of our meshes have more than 1 million cells, which will usually cause FDS to crash when you start it. So that's no good. So what I've done to make it a little bit easier on myself, to make the math a little bit easier, is create the meshes inside Excel. So it'll calculate the number of cells in each mesh, and I can just change these on the fly to kind of do a Gaussian check. Then I also set up these functions so that you can just copy and paste these into FDS. And so at the end of this, you can just make a text document and just copy and paste these into it. And I found that is the most precise way that you can do this. Oops. So saving that as an FDS document, you can open another version of Pyrosim. So now we have the meshes in Pyrosim. We can just copy and paste those into our new model. So voila, we have a model that uses meshes that keep them below 500,000. You'll notice that I stepped my mesh up as I went higher in the building and away from the fire. But I would suggest that for your building and for your model, you play with this a little bit to see what works best for you, and do a mesh resolution study to figure out what the appropriate mesh size is and why.